Hello class, this is lesson 5-4 titled Compare and Order Real Numbers. If we were asked to compare and order 18/5, pi, and radical 11, the easiest way to do this is to turn them all into decimals, and then you can compare the decimals. For instance, 18/5 is the same as 3 3/5, which is 3.6 as a decimal. Pi is a never-ending decimal, but if I put in my calculator, it would be 3.1415 and continue on. Radical 11, again, I would only know this from my calculator, and it would be 3.3166 and so on. So now that I have all three of these in decimal form, I can easily compare them so that I know which is the smallest and which is the biggest. And I could say in order, they would be pi, radical 11, and then 18/5. But we're going to do more examples, and we're going to start with just two numbers at a time. I want you to complete the statement with either less than, greater than, or equal to, and then plot the numbers on a number line. So like we did before, we can use our calculator, and we'll write down the square root of 8, which is a never-ending decimal, but I would round it to 2.82. 2 2/3 would be the decimal 2.66666666 repeating, so I could round that to 2.67. And it's clear to see that 2.82 would be greater than 2.67, so I'll put the greater than symbol. To wrap it up, we're going to go ahead and put these on our number line. So I would put radical 8 just after 2.8, and then 2 2/3 I would put just before 2.7. So I hope that made sense. Let's go ahead and do a few more. Radical 25 divided by 2, and then the square root of 6.25. So I know the square root of 25 is 5. 5 divided by 2 is 2.5. If I use my calculator, I could take the square root of 6.25, which would also be 2.5. So it's clear to see that they are equal, which means on my number line, I'm going to only have 1 point at 2.5, but I'm going to label both square root of 25 over 2 and the square root of 6.25. For our next example, we have negative square root of 6, and we also have negative pi divided by 2. So first I'm going to take the square root of 6, and then I'll make it negative. So that would be negative 2.44 if I round it. And negative pi divided by 2 would be about negative 1.57. So to compare these, the larger the negative number, the smaller it actually is on a number line. So negative 2.44 is less than negative 1.57. This is a common mistake with a lot of students, so just really pay attention to those negatives. So now that I have my number line, I can go ahead and plot negative square root of 6 will be somewhere between negative 2.6 and negative 2.4. And then negative pi divided by 2 would be in between negative 1.6 and negative 1.4, but closer to negative 1.6. For our fourth example, we have negative square root of 5 and negative 210%. So when I take the square root of 5 and I make it negative, I would have negative 2.23 if I round it. And for a percent, I'm going to move my decimal twice to the left, so it would become negative 2.1. And I could see that negative 2.23 would be less than negative 2.1. And now I can go ahead and make my number line. So I'm going to go ahead and just count by tenths. And I'm going to plot negative square root of 5 just between negative 2.3 and negative 2.2. And then negative 210% will be exactly at negative 2.1. Our next example, we're asked to order the set from least to greatest and then plot the numbers on a number line. So I have the set of the square root of 30, 6, 5 4/5, and then 5.36 with a bar over the 6. Like we've been doing, let's go ahead and convert all these into decimals. So the square root of 30 is around, I would say, 5.477. 6 is just the number 6. 5 4/5 is the decimal 5.8. And then 5.36 with a bar over it would be 5.366666 continuing. For some students, it's helpful to add some zeros so that you can compare decimals. But when I do that, I can see that 5.36 with a bar over it would be the smallest decimal, followed by the square root of 30, and then the fraction 5 4/5, followed by the whole number 6. So now I have all four of these written in order from least to greatest. So now I can go ahead and plot these on my number line down below. So I'm going to just count by tenths on my number line, and then I can go ahead and plot them. So 5.36 with a bar over it is just kind of in between 5.3 and 5.4. Square root of 30 would be in between 5.4 and 5.5. 5 4/5 would be right at 5.8, and then 6 would be right at 6, and we're done. Our final example here, we have the square root of 3, we have pi divided by 2, we have 1.60%, and we have 1.35 with a bar over it. So like we've been doing, let's go ahead and turn these all into decimals. The square root of 3 is around 1.73, and it continues on. Pi divided by 2 is around 1.57. 1.60%, I would move it twice to the left, so that would become 0.016. So you got to pay attention to that one. Finally, 1.35 with a bar over the 5 would just be about 1.35. I'm not going to go further than that because I have enough to put these in order. So I'm going to rewrite 1.60% as my smallest number, followed by 1.35 with a bar over it, and then pi divided by 2, and then the square root of 3. Now that I have that in order, I can go ahead and place all of these on my number line. And this time for my number line, I'm going to count by fourths. And I'll go from 0 all the way up to 1.75, and I can go ahead and place my 1.60% very close to 0, followed by 1.35 with a bar over it, just between 1.25 and 1.5. Pi divided by 2 is going to be right after 1.5, and then the square root of 3 would be right before 1.75, and we're done. So I hope that this lesson made sense. This is going to conclude our module. Please let me know if you have any questions when you come into class.